Hi everyone, welcome back to Coding and Analysis. In this video, I'm going to look at the results of the cross-validation and look at the R-square scores and the MAE score position and look at the plotting and the chart. So as we discussed before, the R-square score, 1 is a perfect score and 0 means the model performs no better than just predicting the mean. The MAE score is the average difference between the actual and predicted health grades, and lower is better, so you want close to 0 as possible. So as we did before with the random forest regressor, we start off with an empty list, and it's going to be called position metrics. Then we do a for loop, and then filter on the fancy positions, and then we were saying we want the actual health grades right here, and then the predicted health grades, and the R-square score is going to calculate based on this information, and the mean absolute error to calculate based on the actual health grade and predicted health grade, and then we get this dictionary of data, the position of the player, the R-square score, the position type, and the R-square score in the MAE. So then once we get we're appending this to the empty list, and it's going to create a list of dictionaries. And then we convert the data frame for easy viewing right here. And then we print it out. And then we see here the R-square score is a little bit lower for the running backs. It's still a good score for the wide receivers, tight ends. And the quarterback, it's 0.5. So it's the worst score of the three. But you can still see the MAE score is still low for the running backs, so that's good. 1.84 is the lowest for the wide receivers and tight ends. That's good. And then quarterbacks, it's a little higher at 6.66. And then when we go look at the CSV file for the cross validation, you can see here, I'm going to go up to the top, you can see that there's not really much difference, too much difference. Maybe right here, Jonathan Taylor, which I think that was in the random forest regressor. He had a higher predicted health grade than his actual health grade of 71. Then Ty Chandler still has a 77 predicted health grade, and the health grade was 90, which that was a case-by-case backup score. So it's probably a good grade would be maybe within the 85 or 80 or 85 or something like that. And then we have the rookies for 2025. They're all getting scores of 100. Then we go to the wide receivers, tight ends, which they scored really well. Only 1.84 difference in the MAE score. So you get George Kittle, 88-88. Tyreek Hill, 96-97. George Pickens, 94-94. And then I wanted to look at, Kyle Pitts. I forgot his name in the plotting video. Plotting for the random forest regressor. So it still has 88 and 100. So it didn't really change from the random forest regressor. Right, Cooper, 88-88. Stephon Diggs, 80-82. So it's just fun to look at the differences, or the ones that didn't change at all, like Chris Olave. He had scored up to 76, and the predicted health grade was 76. So let's look at the quarterbacks. Let's see which ones had higher variables. So Jared Goff was 93. His predicted health grade is 93. Patrick Mahomes, so that wasn't very far off. Kyler Murray was but it said about 6 points, so that's about 6 points off. The jerk off is about 7 points off. Cam Ward 99 out of 100. And I think we can see here, you can see that the largest discrepancies right here. Deshaun Watson 71, 35. So him and Anthony Richardson both having a predicted health grade of 72 and 71, while their actual health grades were much, much lower, 35 and 47. So if we go to the plot right here, we're computing the R square and MAE score again, and we're getting the top 5 biggest errors or residuals using NumPy with with the absolute number. And then this is where we're plotting again, just like we did in the previous video. So the x-axis or the horizontal will be the actual health grade, and the vertical or the y-axis will be the predicted health grade. And this is the diagonal line for the predictions. So the min value is starting at 0, and the max value is going to 100, and the diagonal is going to be the two dashes. And this is what the residuals are going to show. It's going to show the player name and the fantasy position. And then we have the titles and axes. This is what we're going to hard code this to get this to show up here nice and pretty. And then we can see here the legend on the location lower right. So you can see the biggest residuals. So Elijah Mitchell, he had a score of 29, and the predicted with the cross validation is giving him 75. So him, Elijah Mitchell, Deshaun Watson, and Anthony Richardson are all getting much higher scores than the actual health grades. And you can see Ricky Parasol, he's getting a much lower score with his predicted health grade than his actual health grade. But then I think that was a case by case basis, since I think I just put 90 for him because he did get injured. He got shot last season, but he did recover. So I'm pretty sure he's going to be close to 90, 100%. But the model, I guess, is taking the data that it didn't play much and putting it down to predicted health grade would be in the 65. And you can see Kyle Pitts right here, his score of 88, even though the actual health grade was 100. So you can just see the differences on the map. And then you can see here we're showing calculating the absolute error right here for all the predictions. They're doing the predicted health grade minus the actual health grade. And then we're sorting by error. So we want the largest errors first. Then we're showing the relevant columns and we're printing them out. So Elijah Mitchell, he had highest discrepancy next to Deshaun Watson and Anthony Richardson, and then Ricky Parasol and Clyde Edwards-Helaire. Then other than those 5, the other ones aren't really too far off. You still have Daniel Jones right here, but that's still showing the quarterback 2023 as the health status is the most important feature importance, and with the 2024 health status is much less feature important. So that's why Daniel Jones is getting such a lower score, just like in the reinforced regressor. But when we look at this and we look at the numbers, what would be a reason why the quarterback, where we're using 5 folds, and the quarterback only has 38 quarterbacks? So it's using dividing 38 by 5, so it's only using like 7 players for the fold. So that's why we're getting probably the big reason why we're getting such big discrepancies for the quarterbacks for some of them. So, with the quarterbacks having such a low number, we're going to have to go in and change that cross validation from 5 to probably around 3. So in the next video, I'm going to write some logic that shows we're changing the cross validation for the quarterbacks to 3, but keeping the running backs at 5 and the wide receivers and tight ends at 5 because they have enough for the model to learn on and calculate. So I'm going to do that in the next video. So like and subscribe and leave a comment. And always remember to never stop coding. And thanks for watching. Bye now.